Thanks, Joe. Good morning, everybody. Good morning. Okay, everybody doing all right? All right. So yeah, like Joe said, you know what Becky and I are going to talk about is using 3D visualization in the RSA process, and part of that is making this accessible for the RSA teams that we put together on these projects. So it's really looking at that and also cost-effective ways to really translate this information to get it into the hands of people who might not be familiar with the whole engineering process. So without further ado, well, let me just tell you basically what we're going to go over. So we're going to talk about the background and the purpose of this FHWA-sponsored project. We'll talk about what we mean when we talk about RSAs. We'll talk about the 3D techniques that we used on this project, again, to get it accessible to this multidisciplinary team, which Becky's going to talk about. Go through a demonstration of one of the projects, and then talk about the different case studies, what were learned, and what were the conclusions from the case studies. So now, without further ado, I'll turn it over to Becky, who's going to talk about some of the background information. Becky.
So I've been on vacation for the past week. We went down to Disney World in Florida. And I was back one day, and I was talking to my mom. My mom's getting ready to get her Social Security for the first time. She's turning 68. She's so excited. And she's like, we've got to go to dinner. We've got to go celebrate my Social Security check. It's like, well, Mom, you know, I can't. I'm getting ready to leave for California. She's like, oh, you know, what are you going to be doing out there? So I told her about, you know, the presentation. And she kind of chuckled and laughed. And she said, oh, my gosh, I can't believe you're talking about technology. Do you remember blah, blah, blah? And just to give you all a quick story, my mom was really a pioneer in terms of a woman being in programming. Right out of college, she did an internship with IBM, started working for IBM. Eventually owned her own consulting firm where she was working with different agencies in Virginia doing programming work. And she was the type of person that we had an office in our basement, and you know, she'd program all night. She's the type you just slide the food, you know, kind of underneath the door. She always had long nails, and I could just always, you know, now I'm forward in the computer. But just loved it, still loves it. She's still in information technology today. But quick story, my mom back in '81 purchased this big honkin' IBM System 23. And she invited me to come down into her office. She said, you know, I got my new system, and I'd really like for you to meet it, so come down. So I'm like, okay, you know, and so she says, well, sit down because it wants to tell you something. So she had written a program so that when, you know, I touched one of the keys, it said, hello, Becca, how are you doing today? And it scared me to death. I was like, this machine is alive. And I swore right then and there, I will never work with computers. Mom, you are a freak. You know, you stay down there all night, you know, programming. But anyway, so she got a chuckle when I told her that I was going to be coming out here and talking about visualization and this project. And she said, oh, you know, never say never. You never know what you'll be doing. So isn't that the truth? But anyway, this is the one little tidbit she did tell me. She said, yeah, I spent $10,000 on that machine. And then a month later, they came out with the personal computer. So, oh, how things change. So we did sponsor this project. When I first came on the job about 6 years ago at the Office of Safety and took over the Road Safety Audit Program, the RSA program, you know, I was looking over all the projects that we had ongoing. We'd had a lot of success with the program. A lot of state DOTs were actually initiating the process and using it in their work. But I didn't see a lot of road safety audits being used on designs. So we were doing a lot of road safety audits after the project was built, but we weren't doing a lot of reviews before the projects were built. And I thought, this is really where we need to be doing these reviews and where we need to be getting these teams together. Let's get these things corrected before we put it out on the street. And so my boss looked at me and she said, that's a great idea, but how do you propose we do that? And we had a partnership with another office in our agency, the Office of Infrastructure. They were funding new technologies. It was called Highways for Life. And I kind of wrote a little proposal up and said, you know, I think it would be awesome if we could visualize the project and then bring a team of experts in to physically, you know, walk through that design and point out deficiencies in areas where we could enhance safety. And they liked the idea. They actually funded it, and that's where the case studies came from. We did 4 different RSAs in 4 different areas of the country, and we're getting ready to finalize. The document's been in the final draft, and we're getting ready to finalize that and put it up on our website, hopefully in the next week or 2. And why did we do it? We want to help, you know, other agencies, other DOTs, other federal agencies, tribal agencies learn from this. We wanted to capture all of these RSAs, what we learned from using this 3D visualization, with the hopes that they're going to be able to take this technology and use it as well. Why 3D visualization? You all have heard this. I heard this yesterday a couple times in presentations. In the current transportation legislation, there was some discussion about innovative technologies. You know, Section 1304, 1503, and then our Everyday Counts initiative that's been really spearheaded by our Administrator Mendez, and our SHARP 2 initiative, our research project. They're really pushing that state DOTs, you know, look at how they can better use technology to do their work. So why 3D visualization? I gave you all a little hint a little bit earlier. You know, we want people that are going out and looking at a design to really understand what's in that design. And sometimes when you're looking at those static plan sheets, I don't know if you all, I'm from Virginia, and we just got finished up on the Woodrow Wilson Bridge, and there's a whole room that's dedicated to plans. I mean, huge rolls of plans. And I can't imagine having a team, you know, going through those plans and trying to determine, you know, the safety of that project. So this just is a tool that we wanted to use to really give us that awareness of safety on a project. So before we get into the glamorous part, I'm sorry, we have to talk about road safety audits. I know the visualization stuff is more fun, but before we go there, you know, look at this picture. How many times have you been riding down the road, you see the blue lights flashing, and then you come up on a crash and you see really something devastating, like this picture. So, you know, first, let's begin with the end in mind. You know, we want to reduce these. You know, the saddest crash I've ever seen is we were on our way to the beach, and we were headed down 95, and it was a Tahoe. It looked like it had flipped like 4 or 5 times, and people had been thrown from the vehicle, and their dog had been thrown from the vehicle. And, you know, it sticks out in my mind. I'll never forget that. But, you know, this is why I'm in the business I'm in. I don't want to see that. I don't want to see these crashes on the road. So whatever technology, whatever process that we can implement to stop these crashes, I am all for it. So what is an RSA? It's a formal safety performance examination. It's done on a future road or an existing road. It's independent, and there's a multidisciplinary team. The reason that we have these particular words underlined is because this is what makes it different from just a typical safety review. We want it to be formalized. We want things to be written. We want a written report. We're truly focused on examining the safety performance of the roadway. We want independence. We want people on our team that aren't very familiar with the project. We want them to give us a fresh viewpoint. You know, what do you see when you look at this? You know, a lot of times if you're engaged with that project on a day-to-day basis, you're not going to see things that someone coming in fresh is going to see. So we want that independence, and then we want a multidisciplinary team. We want law enforcement. They see what's going on the roadway. We want someone with a human factors background. You know, they can see things that, you know, engineers, planners, they might not necessarily see. We want operations folks out there. So we want this multidisciplinary team to come together and do this safety performance examination. It's an 8-step process. This shows you kind of all of the different steps and the different responsibilities of the team, and then of like the design team and the project owner. I'm going to go through each one of these steps fairly quickly. So first, you have to identify that RSA project. And as I said earlier, it could be any project. Typically, we like to see maybe a complex design, or maybe a roadway where its function has changed, and so there are different things now happening on the roadway. You know, maybe it's a location that's inaccessible. You can't actually go out and walk it. That might be a great candidate. Or an innovative design. You're going to be hearing about an innovative design later today. So these are kind of the types of projects that we would look for. And then selecting that RSA team, to me, this is probably the most critical step. I talked a little bit earlier about, you know, that multidisciplinary aspect. You know, you want that core skill set to be geometrics, engineering, human factors. You may have an area that has a lot of pedestrian and bicyclists. You know, you might want that skill set on your team. So it is imperative that you get the right people on your team to actually be reviewing your project. And then step 3 is, this is when your team is going to start looking at that data. You know, what are the crashes out there? What's our traffic volume? What are the characteristics of the roadway? This is where you're going to be looking at any drawings that you have. And this picture down here, this was from our Rhode Island case study. And this team, this was actually our introductory meeting where we had everybody, the road owner, come to the table, and we started talking about the RSA process and what we were going to be doing. But that little bullet in red, that's really, in terms of the 3D visualization, this is going to be the first place you're going to be seeing that come in. We're going to start introducing how we're going to be using visualization in the project. Step 4, even when it's a design, we want to go out into the field and see what's going on out there. You know, some of these designs, we weren't making a lot of changes. Some of these were a complete redesign of the roadway. But you want to do the field review. It's extremely important. You want to see the conditions. You want to see how traffic's moving. It's great to have law enforcement out there with you, especially if it's a very complex design. They're sitting there beside you saying, well, how am I going to pull anybody over on this? You know, or you've got traffic signals that don't make any sense. I can't go to court and defend this. So they bring a really unique perspective when you're out there on the field. And then that step 5, this is really when you're going to start doing your analysis. And you're going to be, you know, sitting across the table with your team, and you've got all this data in front of you, and you've been out in the field, and this is really when you're going to start working together and talking about, you know, this didn't look right to me. This didn't feel right to me. What do you think about this, you know, characteristic of the roadway? How are people gonna really understand what to do? So this is where you're going to start doing that analysis, and you're going to start identifying the issues, prioritizing those, and start to think about, you know, what types of countermeasures should we really recommend to make this design safer. And then this step 6, this is where you start writing the report. You know, you've done that analysis, you've come to some consensus of what you'd like to see changed. And like I said earlier, it's formal. You want to actually write a report and get everyone's comments and input. Here's your formal response that you're going to actually be sending to that road owner. And then finally, you the road owner is going to give you that response back as to which of those issues maybe they can move forward with, maybe those issues that they can't move forward with due to funding or other reasons. And then, this is the final step. We want to see those things incorporated into the design. And on every RSA that I've ever been on, it's amazing how when you have operations folks out there and they see something wrong, they're on the phone immediately. You don't even have to wait till this, your formal response back to the road owner or incorporating. They're out there now. They're getting signs changed. They're cutting, brush down from the road so to make sight distance better. It's just amazing how quickly they work. But that does give you some idea of the 8 steps for an RSA. I am going to now turn it over to Dan, and he gets to talk about the fun stuff. But Dan, all
right. Thanks, Becky. So this is the fun part. Everybody should be excited, right? So we're going to talk about the models that we developed for this project. And first going to start off by telling you, what basically we put together. So you see, we were developing realistic models, and those models they had like all the traffic control that was part of the proposed change, pavement markings, lane configurations. You could see all the attributes there on the road and the roadside to give it a realistic feel. The purpose of this was to be able to drive down the roadway and look at it, what it might look like if it was a completed project, to give this multidisciplinary team that sense of completion. And it makes it easier for them to be able to identify, some of the challenges or some of the potential things that might be of concern from a safety standpoint. Now, the other important point of this was that we put this in a format that was easily accessible because, again, we had these multidisciplinary teams. Not everybody was well-versed in engineering drawings or shop drawings or technical aspects of designs. And so we wanted to put this in this PDF format so the PDF software is available for free. We could send this to them or put it up on a website so that they could, download it themselves and kind of look through the different designs prior to going into the meeting. And if there were some adjustments that needed to be made, we can do those before, we actually kicked off the RSA. So that was the real benefit of using that particular platform because it meant everybody could use it. You didn't have to be an engineer. You didn't have to have special software. Some of the interesting aspects of it, of course, like I said, it's the intention was to give a realistic design of the roadway so that you could drive through or walk through it, and then you could rotate the different models 360 degrees to kind of get different viewpoints, and that really enabled the teams to get a thorough understanding of the placement of different things like your signs with respect to the roadway, where were some of the sight distance limitations, where were just some things that maybe weren't really completely thought through in some of the preliminary concepts that needed to be incorporated into the design. And then finally, the last control feature was that we did this so that we had preset stations, the stationing for the project. Basically, we followed that stationing so that they could click directly to different stations if they wanted to look in a specific area. And I'll demonstrate that for you in a few minutes. So how did we put this information together? Well, first of all is displaying the information and really breaking out that information, where we took your digital terrain models or 3D contours, if that's what we had, to really make the surfaces, to really make sure they were smooth and connected so that we would have separate layers for different surfaces for the road, for the roadside and different things too, so that they could be displayed and kind of overlaid with different surface materials. Next, we created 3D objects outside of our design software package, and that was usually done in SketchUp or something similar to that. So we created those and imported those into the design software and placed those in the appropriate location according to the design. Then, like I said, after looking at the information that we displayed, we would create the surface materials for the road, the grass, and different things like that. Then we set these 100-foot view locations. So that's basically what we did. And then finally, of course, we would take that and then create a 3D PDF from that design software. And we usually use MicroStation for putting this all together. So what does that look like? Now I'm going to show you one example of one of the roads that we looked at. This is a case study in Virginia, and we'll go through this in a little bit more detail, but I want to show you how it works, basically. So, like I said, we had these models developed, and we had these preset stations marked out. So you could click through, and it kind of simulates driving. You could also drive through by using, the mouse or whatever in the cursor. You can also rotate, as you see, to looking at things isometrically, get a bird's eye view. You can see you can zoom in there too, and you can see there's quite a bit of detail in a lot of these things. Everybody recognize this? I know we're not putting a plug for a special convenience store or anything, but you might be able to recognize that as a 7-Eleven. So we'd have some realistic features here, and part of having the realism is to get buy-in from people who are going to be reviewing the model and evaluating the safety aspects. This particular one of the concerns on this, which I'll talk about in a little more detail, was this new roadway is basically a widening and a realignment. And one of the concerns was the impacts on this neighboring community here. So this kind of really demonstrated to the public, what the final design would look like and what, how that would affect their community. So that was kind of that neat aspect of that. But you can see signs are also displayed there. So we have the signing and marking plans which are put in the models. Pretty realistic depiction of what we're looking at. You see lighting through here, fences. We also have retainment ponds for runoff. So again, we're depicting every single feature that's out on the roadway in a realistic fashion. I'll just click through going in each direction. And you notice too, what I'm doing is it's going, by having these preset stations, it's going in one direction and the other, so you can kind of see where you are and you can click to it too by just clicking on this menu off to the left. So that tells you exactly where we are. But you can also see where the new and old roadway alignment difference is. So, when you have that fresh repaving, you have that kind of darker asphalt color. Well, that's in there too. And you can see retaining walls that were needed for the widening. That's all depicted. So it's pretty real. Again, people bought into this because it depicted conditions that they could expect if the project were complete. All right. So let's continue on talking about some of the case studies and how this was utilized. So there's 4 case studies I'm going to go through. And we'll talk about some of the different benefits that the 3D model that we used really was realized from each of these. So the first one is Defense Highway, Burma Road in Middletown, Rhode Island, and that's one that Becky had referred to as well. The planned improvements here, where it's a two-lane new facility that goes through a Navy base. So because of that, we didn't have access to it's closed to the public, so we didn't have access to the area where the roadway was going to be proposed. So we looked at developing a 3D model for that section that was part of the Navy base. This was a preliminary concept, so because of that, we didn't have a lot of detailed information available. We didn't have site survey or anything where we could develop those digital terrain models. So what we had to do is we had to use the state's GIS contour file to kind of create that 3D element there. And as you can see, what we did is we overlaid the 3D model. You can kind of see the extents in this aerial view from this roundabout to that roundabout. We overlaid that on just a map of the base and using that GIS contours and their existing aerial photography. So again, we were just looked at one section, and this one section that we looked at, actually there was a couple design alternatives for some of the intersections, which I'll talk about a little bit more. But this one section was just that part that was on the base that we didn't really have access to. The RSA was much larger, and it was kind of interesting because it provided us a basis to compare, looking at the model, using the model, and looking at the area where we didn't use the model. But in this case, it was a necessity to use that model because we didn't really have access. So what were some of the benefits of using that on this facility? Well, one was, again, that just having that visualization of what it looks like what the road would look like on that base. And that was important because the impacts to the base, they were going through a partial base closure, and they wanted to know if they were going to turn this over to the public, this section of the base for a public road, what would be the impacts to their land and also their operations too, with the different gates that they have going in and out of the base. It enabled comparison of those impacts. Like I had mentioned very briefly, is that we had two design concepts. We had on your left here, you can see a visualization of having that connector road terminate at two signalized intersections. The other concept was having it terminate in two roundabout designs. Well, by having this detailed 3D visualization, you could see not only from a plan view, but you could see from a real-world 3D view what are the impacts to, this is a housing area, what were impacts to housing areas in all quadrants, and also some of the trees that were used to help shield again some of the developments, and also the base itself. You can see here's the fence is depicted on this view with the roundabout as well. So what were the impacts to the base? Some of the other things were a visualization of concepts that were pretty unfamiliar to a lot of people in this area, particularly with regards to being so close to a naval base. And one of those was the use of roundabouts. So you can see in these two bottom photos here, you get a nice isometric view on the bottom left, but then what we were able to do is kind of drive through that roundabout as well and show what were some of the key attributes to that roundabout that would really be an added safety benefit. And this specific attribute here that we're trying to demonstrate is that deflection through a roundabout, which helps to slow down vehicles. The speeds were a big concern here, and having that ability to slow down vehicles was critical. So that roundabout idea was seen as a good benefit because that would help address that specific issue. The other thing, too, you can see this is a photo of driving down that existing road, and you see the sun comes up right along that roadway. Well, one of the benefits of having roundabouts, which you could really visualize through this 3D model, is that you have your pavement markings on the road. So if this were a signal, you would have difficulties really seeing what were the indications on that signal due to the sun coming up at that time. Here, by demonstrating the 3D model used on the roundabout, you could see, well, you're looking down on the road, you have your pavement markings there, so you're less likely to be confused coming into that intersection. So it really brought some of those things to life. And ultimately, what happened is the Rhode Island DOT, they developed a policy or plans through other areas or through other connecting corridors of putting in these roundabouts in pairs to have this kind of dog bone formation where you have two roundabouts, which really helps slow down vehicles, like I said, but it also helps with vehicle access. Because if you have access points in between those two roundabouts, you can put in medians, and that really helps provide an opportunity to have an access management plan. So again, that building support isn't like supporting buildings, but building support through being able to clearly demonstrate these models was one of the key benefits. And again, by doing that 3D format, that PDF format, it was very, very easy to transfer that to multiple stakeholders, which we have on a lot of these projects. The last one for this specific project is, looking at things from that isometric view just gives you a better vision, a better clarity of some of the impacts. And through that, a design change was made to this roundabout, or a design recommendation of moving this roundabout to this side street right here to make a 4-leg roundabout rather than keeping it where it was originally proposed. So again, really helping to clarify what are the impacts of different decisions with a specific design. So the next one I'm going to talk about is very, very different. It's an interchange project where we looked at specific modifications with regard to two interchanges. And one of them was modeled. You can see off to the right here, we're talking about a new on-ramp new on-ramp to I-90, and the other one is just a right turn lane to help improve capacity in another intersection. So this one was a little bit further in terms of where it was in the design stage. This is conceptual instead of preliminary design like the other one. So we did have existing and proposed digital train model of the surface. We also had the design in 3D CAD, and we had the latest signing and pavement markings as well. So again, we looked at 2 interchanges, but this one that's circled in red here is the one that we looked at, and you can see this is kind of a blow-up of a couple of the features on there. So what were some of the benefits of looking at this using 3D visualization at this interchange project? Well, one is to evaluate the impacts that really weren't thought of up until that 3D model was developed. And one of those is, utility impacts. Utilities, lighting, how are those going to be impacted by the new design? On your left, you can see this is the existing design, and on your right, this is the proposed design, and it would impact, you can see some of the utility poles that it would impact. The other thing, too, is, by actually designing this in that 3D model, by putting it into an actual design, we're able to see what were some of the constraints with that proposed design. So, for instance, this new on-ramp that you see here, this is kind of like the arterial street, and this is the on-ramp to I-90. By actually putting that into a design to make it into this 3D model, we looked at, okay, what is the radius of this, and what is the corresponding speed given that radius? Well, the speed of this ramp would be 25 miles an hour, meaning you'd have a much, much, much longer acceleration lane. And so there's an immediate impact by doing this in 3D design that we're able to clarify. And that led to a better understanding of how these elements come together all in all. Again, this is something Becky talked about, the visualization and understanding. It led to better participation, and this was especially critical because we had several design alternatives. I focused on 2 things, but we had many different options that we considered. And by able to visualize them, we could compare those. And basically what we were able to do is come up with advantages and disadvantages of each that we really wouldn't have been able to do without that kind of 3-dimensional design. So here's just 2, but we actually came up with 7. And I'm not going to go through all of them, but you can just see that that was like real benefits. So we could get more clarity as to what were the impacts of the different alternatives. Also, again, looking at thorough understanding of impacts, and that's not just from a design perspective, like I talked about that curve on that on-ramp, but it's also operational impacts too. It helped provide an understanding. You can see on the left there's a photo of the existing road, and then we talked about that proposed right turn lane. Well, this is the new proposed road with that right turn lane, but what was happening here is you had this long queue of right turning vehicles, and now this is the condition where you don't have a right turn lane, and that was creating sight distance problems for, as you can see, this truck coming out there, and there was collisions associated with that. So we were able to assess those impacts by looking at how that design was changed and make recommendations to address some of those things that weren't addressed through that initial design. Okay, and then the third project we'll talk about, this was very different than the other 2. This was the model that I showed you. I kind of ran through very quickly. This is a roadway widening and a horizontal and vertical alignment of this road that was next to this it was next to this community, this neighborhood. So part of it was a widening up to that community, again, to provide them more access. It's a little bit bigger. This just shows like one of the road that was closest to the widening that would be impacted the most. And then a realignment of the roadway in this section where there's some significant horizontal and vertical curvature. So this was in the 90% design stage, this project. It was nearly complete. There had already been an environmental assessment done. There was approval. So, we could model things more precisely, but there was also a little bit less flexibility in changes without, completely disrupting that whole process. Well, we were able to make significant recommendations based off of what we were provided. This just, again, shows how realistic the model is compared to an aerial photograph right there. So one of the things was to provide that thorough understanding of the impacts to stakeholders, because stakeholders for a long time, the community and other people had been really pushing back on this project because they felt that it was going to completely disrupt their community. Well, we were able to have this realistic depiction of the conditions that had built confidence, and people were more accepting of the impacts, the potential impacts of this project. The other thing that we did with the model is, I showed you the run through of the actual model before, is we kind of did that, and we did a taping of that so that we were able to put that on a computer in a public meeting. It just kind of ran so people could just sit there and watch that without somebody having to actually drive or work the controls. So that was another neat aspect. They were able to do that very, very easily by having it in that PDF format. Another thing is, again, that ability to drive through that really, again, provided a clear understanding to some of the potential impacts. This is actually looking west where you're coming up to that intersection, and you can see it's 3 lanes there, which is different than the condition now because it's only 1 lane, except for right at the intersection where you have a left turn lane. But this right turn lane, if you're looking at this, there is some elevation here, and you can maybe just barely see there's actually that convenience store is in this corner. So this right turn, if you're going on this road, you might think it's the right turn to that intersection, but it's not. It's the right turn into the 7-Eleven. So, having more clarity, being able to see it from that driver's perspective, helped identify some of these issues, and so we were able to address them before they were actually put into the ground. All right, and our last project, and this is probably the most complex of all the projects. This is basically a junction of a new freeway and an interstate. So there's and that would create 2 new interchanges, partial interstate rewidening, and significant realignment of frontage roads that are along the existing interstate. This is a preliminary design, so we had survey, we had a lot of good information, we had their digital train models and 3D CAD, but I would say it's probably like at the 40% stage, but there was still some flexibility to do things within the right-of-way. This is just an aerial view of the entire area that was modeled, so we're looking at this area in the box, and here's kind of these purple roads are the new, this is a new, this is the Mid-County Parkway, which is a new facility, which would create this new interchange, and then because of the realignment of some other roadways, it would create this new interchange here, or it would create a modification to this, making it a more elaborate interchange. So, again, with the significant changes here, the 3D visualization helped in several ways. We were able to look at the impacts of the different bridge piers, abutments, the different barriers and the sight distance problems it would cause, the location of some of the signage that was being proposed. So we were able to see things immediately that we could put into the design to make sure that they were being addressed. The other thing too, and I'll try to explain this, you see that this is an old frontage road here, and this is the kind of grayed out area is the old frontage road, and the new proposed design in red is kind of moving this as an off-ramp, and the old frontage road is coming over to the east a little bit more. So you're looking at from the 3D model perspective, you're driving down this roadway and you're still seeing your old intersection in, almost straight ahead of you. And so recognizing some of those impacts, looking at some of the familiarity some of the drivers might have and how they might be affected by these significant changes were things that were really clarified through the use of this 3D model. And again, we can come up with measures how to address them. I think maybe one of the things that was a surprise was that the basic footprint of this conceptual design was already created. And one of the things that hadn't been done was the signage plan. Now, you usually think of the signage plan as something that comes afterwards. Well, since this is such a complex interchange, as you could see, we kind of came up with a preliminary signage plan and as part of this RSA. And by doing that, we realized, okay, we would need some significant signs that would require overhead signage. And with that, the overhead signs have barrier requirements. And when you have a barrier requirement, that requires a grading change. And so what we're able to do is realize it comes back to the initial design where you're going to have to make some grading changes in that alignment in order to put in the signs that were really needed to help people navigate this new complex interchange. And that was something that I think that was maybe not expected by doing this RSA, is that the signs would kind of come back to grading. And so what we're able to realize is that to have a more holistic approach and kind of doing things together was really, really needed. And so, based off of the findings, they went back and figured out that signage plan, which would result in some grading changes and also some small alignment changes or some shoulders and some other things of the roadway, which, again, wasn't really anticipated when we were going into this, but was something that was really seen as a benefit from using that model. So, all in all, some of the benefits that we saw by using this 3D visualization is this comprehensive design plans. Again, we had teams that were put together. We had law enforcement. We had, other people who were involved that are critical to this process and who aren't familiar with looking at a flat set of plans. And so they were able to really provide really good creative input by being able to see the roadway from this driver's perspective. Law enforcement, they're familiar with things that they enforce on the roadway, with problems that they see, and they're able to kind of see how those would translate by being able to see it in this context. Of course, looking at the proposed features, that was another benefit too, and having a thorough understanding of those. When we're talking about median islands or talking about roundabouts or pavement markings, this provided a realistic context so people would understand, oh, okay, well, this makes sense to me, or should we be doing something different? Provide that visual support that different participants in the RSA process could use, from the owners to different stakeholders, and so that they would realize, their concerns could be addressed up front. And so the design would even be better if we're addressing some of the stakeholders' concerns up front, rather than waiting later to when it would require significant changes in the project schedule. You can do this up front earlier and keep things on track pretty much. The other thing, too, is looking at different vantage points, the isometric views, and looking at locations that you wouldn't be able to assess because they're inaccessible for one reason or another. I gave you the example of the Navy facility. We didn't have access there, and we wouldn't really been able to understand that very well by just looking at a flat plan. And this way we're able to drive it and see, what were the best types of facilities. In this case, we came back to the roundabout, and that provided such the support for that was so huge that it again became part of a policy that the DOT adopted. The holistic approach, I mentioned that with the signs on that last example and that freeway new interchange in California. Something that you wouldn't really expect, but your final design elements could impact significant designs up front, and this really helped bring that to the front by looking at this 3D model. And then, of course, what's probably really important, too, is when we pull together these teams, we have a team of experts that's providing this very focused input. We're getting this expertise for a short amount of time. And so this really helps ensure that we're maximizing that expertise, because they're able to provide the most thorough input that they can, because they have the most efficient and quickest understanding of what is going on or what's being proposed through a certain design. So with that, maybe we'll hold questions to the end, or how we'll do it. Okay, are there any questions? Yes.
When you say existing, do you mean like survey data, or it's just like an as-built type of CAD model?
Yeah, it's, we took, on some of it was, we would use both. We would have to bring it into, some design software and actually create the DTM based on that. But we took just survey data sometimes and created the digital terrain models.
Okay, so, well, first, I think this is a great approach, and I think it's a great use of 3D visualization. And would you be receptive to some suggestions?
Sure.
Like the DTMs, there's the JPL lab, very close to here.
Yeah.
They manage a Terra satellite project, and under the Terra satellite project, there's a sensor called ASTER. It was put together by NASA and the Japanese Space Agency, and they've done DTMs for about 80% of the world. And
wow.
It's all free. You can go to the JPL website and download the DTMs.
Wow.
Another thing that I was looking at is, like, our vehicles now, we have LiDAR, grade, and photo logs all integrated. And we try to port them right into a workspace that's 3D. And one of the things that one of the projects that we ran into was we had a kind of a country highway, winding road, and without this data, you couldn't see that the drainage, they had extended the drainage slope too far into the super elevation into a curve, right? And it wouldn't be an issue until it was raining. So when we brought the data into 3D visualization workspace and turned on different weather conditions like storm, you could see that type of environment. But what I'm saying is that as-built are good for general reference, but if they're not.
Yeah, they're not always completely accurate. So yes.
The subtleness of the change was, you wouldn't capture it. The as-built never showed it and would never show that problem. But with the data right out of our data collection vehicles, the LiDAR data, and the photolog imagery, and the curve and grade, it's very easy.
Yeah, no, and those are two great resources. The first one I certainly didn't know about, the JPLs, that they have that much data.
Yeah,
one of the
it's huge. The satellite has been up since about 2000.
Wow.
And it's continuously collecting a lot of. I mean, the Terra project has a lot of sensors to basically monitor the Earth over time.
Thanks.
And it has many uses, but one of the key sensors is the Aster, and the Japanese and NASA have done a good job of making it completely free and available to everybody to download.
That's great. I'll definitely check into that. And, that reminds me, one other thing that I'll just point out, too, is that, part of this, too, is looking at how, this could be done really quickly, because we had very short time frame for most of these. And so, we had to do these, to develop each of these models probably took about somewhere in the ballpark of 100 man-hours. For each of the projects, and some of them had multiple designs, multiple alternatives. I talked about one where we had two intersectional alternatives, another one where we had multiple alternatives. So that's kind of the benefit, is that you're getting something pretty quickly with here. But on bigger projects, I definitely can see.
That's a lot of time. If you have the LiDAR right in, and you can set up your initial parameters within a couple hours easily.
Yeah. Any other questions? Yes, right here.
Yeah, I wonder if, trying to tail in onto that, if you've used Google Street View at all for the locations where it's available, which is most of the U.S. now, I think, but to help with seeing things like culverts or whatever, where
Culverts
sometimes
is very
design
difficult,
plans-
right? Culverts is, a lot of them are off the side of a
Yeah.
hill.
Yeah, but that would be one way of trying to get some quick views, also to try to see if your model from the as-built is accurate enough for representing. And then I had another question, is that Rebecca mentioned something on road safety audits aren't only on new development, right, or change outs. Are they also on existing conditions of it? And are you having a problem getting data to model those if there are locations that don't have CAD, ready CAD design data available, or maybe they're only in PDFs, do you have to rebuild stuff?
I think that was some of the problems that we had.
Yeah, but I will say, if we're looking at something that's just an existing facility, we don't usually do the model because we can actually walk or drive it. So this is more towards, when we have a design plan where, we're really trying to look at how this final design will incorporate in with an existing roadway somehow. So, I would say that on existing ones, we kind of just go out, walk, drive, bike, or whatever is required. So we have a little bit different process. This was kind of new in that, we do these on planned or proposed projects, but again, we're just looking at, flat drawings, and you have these kind of big teams put together that don't always get everything they're looking at. And this was a tool where they could understand what was going to be put out on the roadway, or what was it planned.
And then the other follow-up to that is, have you looked at trying to bring traffic in, or especially if there's like a traffic control problem where you have the law enforcement involved with, if there's some issue, that may help visualization as well.
Yes, and we put in, we did put in like stationary vehicles, so you could see like what were the impacts if somebody's stopped at a location. We didn't have simulation incorporated with this, but that would obviously be an interesting next step to see, you know, that kind of operational aspect. But we did have static vehicles placed to look at things from a safety perspective.